17 is one that always trips people up just because it's a word problem. But once you figure out mathematically what you have to do, it's not that bad. A cereal manufacturer uses 3 large overhead bins to hold the 3 ingredients in one of its cereal mixes. Bin A delivers a pre-measured quantity of dried fruit every 25 minutes. Bin B delivers raisins every 10 minutes. And Bin C delivers flakes every 15 minutes. If they start the morning shift at the same time, how long before they deliver their ingredients at the same time again? So, some people just start listing out minutes. And if you list out minutes, what are you looking for?
Same time.
The same time. Okay, so what you're really looking for, mathematically speaking, is the least common multiple. You want to know what's the first number they have in common. So really 17, the cereal problem, is just a least common multiple problem. So if I look at my numbers again, I have the number 25, and I have the number 10, and I have the number 15. So if I just list these numbers out, and I just start listing multiples, well, 25, I've got 25, and then times 2 is 50, times 3 is 75, times 4 is 100, 125, and I'm going to stop because I'm out of room. Hopefully, I'll be able to figure this out. 10, you know, is 10, 20, 30, 40, 50, 60, and so on. So really the only thing I see in common between these two numbers is the number 50. 15, I've got 15, 30, 45, 60, 75, 90. I don't have a number that all 3 of them have in common yet, do I? So this listing method, yeah, it'll work if I want to keep listing them out, but I like to do factor trees. So listing, yeah, you'd eventually get it, but what if, remember, keep in mind you're not using a calculator on this part. So if you had a calculator, sure, I could keep punching that in and figuring that out, but it's getting kind of tedious. So when I find least common multiples, I like to do factor trees, because it's a good way to help just organize my work. Plus, it seems to be less work sometimes anyway. So, if I have 25, which is just 5 times 5, and I have the number 10, which is just 2 times 5, and I have the number 15, which is just 3 times 5. Since I have 3 of them, I need to look and see, do all 3 of them have anything in common? They all seem to have a 5. I'm a visual person, so I like to think in terms of circles here. And I know that my math lab doesn't show you this part. And actually my circles are a little small, but you'll get the idea. So I've got a 5 that's in common in all of them. So I put a 5 right there in the middle where they all overlap. And then that's it. Now this number still has a 5, and that number still has a 2, and that number still has a 3. But if I were looking for a greatest common factor, a factor that they all have in common, it would be 5, because 5 goes into all of them. But I'm looking for the LCM. So the LCM is going to be whatever, everything I see in my circles multiplied together. So 5 times 5 times 2 times 3. And whatever that ends up being is my LCM. So that's 25 times 2 is 50. Oh, it looks like 150. Which in my list, I didn't get that high in my list. I kind of ran out of space. So 150. So every 150 minutes, all 3 bins are dropping ingredients. You've got some bins kind of sporadically in between, but every 150 minutes, all 3 of them contribute to the cereal at the same time. So it really is just an LCM problem in disguise. You can list it out until you find something in common with all three numbers, or you can do factor trees and figure out LCM this way. And some people, they'll do the factor trees, but then they don't do the circles. They just look to see, oh, they have everything 5 in common, so I write down a 5. And then everything that you see in common, you write down just one time. And then you throw everything else in. But that's least common multiple. And you can use that method when you're trying to find a common denominator if you're dealing with fractions, which the next one is a perfect example of when I might use factor trees to help me with adding fractions, because I have a 4, a 12, and a 15. So trying to find a common denominator might be a little tricky on 19. So let's look at 19. See if we can use this idea again. So 19, I have 2 fourths, I have 6 twelfths, and I have 3 fifteenths. Now you can actually do this problem a couple different ways. Because I notice that those fractions right there, they're not reduced. They're not simplified. I could actually simplify them first, get smaller numbers to work with, and that's probably going to make them a little bit easier. Now you could work with them like this too, but you're dealing with 15, 12, and 4. A least common multiple between those three numbers probably will be end up being, I would guess, in the hundreds. But if we reduce it, 2 fourths, that's the same thing as what? Two fourths reduced? Anyone? Anyone? How about 1/2? Yeah, 1/2. What about 6 twelfths? Ooh, that's 1/2 again. And 3 fifteenths would reduce to? Because you can take a 3 out of the top and the bottom. 1/5. So now I just went from 3 different denominators to 2 different denominators, and they're little numbers. So, what's a common denominator between 2 and 5? What's the first number that 2 and 5 both go into? If I were to list the multiples of 2 and 5, what would be the first one that they'd have in common? 10. They both go into 10. So what I need to happen is I need all of the denominators to be 10. So how do I get from 2 to 10? That's a multiplication of 5, which gives me a new numerator, because 1 times 5 is 5. Now, since it's 1/2 plus 1/2, I know automatically that's going to be the same thing. How do I get from 5 to 10? That's a multiplication of 2. So my new numerator is 2. Now that all my denominators are the same, all I have to do is add my numerators. 5 plus 5 plus 2. And that would be 12. And the directions do say simplify. Now, they don't say write as a mixed number, so you could actually just simplify it and leave it as, let's see here, 2 goes into both of them, so it would be 6/5. If it said write as a mixed number, then we'd have one more step there. But like I said, you didn't have to reduce it if you didn't recognize that you could make it simpler before you started. You would just have to find a least common multiple between 4, 12, and 15. Which I believe ends up being like maybe 120. I think is the first number that all three of those go into. And when we reduce, our common denominator was 10. So a little bit easier to work with. Alright, 21 is subtract and simplify, and it's a common denominator. So that's kind of nice. 21, we have 42 over 56 minus 40 over 56. So that's going to give me an answer of 2 over 56, which definitely reduces to what? 2 goes into 2 one time, and 2 goes into 56 how many times? goes in twice into 5, and it goes in 8 times into 16. So it looks like 1 over 28 would be my final answer on 21. Now 23 moves on to, it's still subtracting, but we have a whole number minus a mixed number. So how do we deal with that? And there's actually 2 different ways we can deal with that one. Let's see, we have 19 minus 9 and 6/7. So we don't have anything sitting next to the 19 that we can use to subtract. But what we could do is we could rewrite the number 19. We could borrow or rename. So I'm going to rewrite it. But instead of 19, I'm going to rewrite it as 18. So I'm going to borrow 1 whole. And how am I going to write that? I'm going to write it as 7 over 7. Because would you agree that 7 over 7 is the same thing as 1? So 18 and 1 makes 19. Now the reason, why did I do 7 over 7? How come did I just randomly pick that number? No, I need a common denominator of 7. So I need to rewrite that fractional part with a denominator of 7 because I need them to be like denominators. Now I can subtract. So 7/7 minus 6/7 is 1/7. And 18 minus 9 is 9. So 9 and 1/7. Now do they want it as a mixed number? I'm assuming they do. Yes, they do. So 9 and 1/7 is the answer. The other way that you could have done that problem is you could have converted the 19 and the 9 and 6/7 into fraction notation and then get a common denominator from there. The only problem with doing it that route is you get really big numbers and it's a lot of work. So this one actually isn't too bad. Just borrowing 1 whole.